Hey everybody, it's Dr. Patterson again. In this video, I'm going to walk through the circuit for the first week in mechatronics, and we're going to use a couple switches and 6 LEDs for this one. If you haven't looked at the tasks yet, not a big deal. You need this circuit to be able to do those. So what we're going to do is start with, you can see the board up here. I'm not going to build yet. What I'm going to do is draw out part of the circuit and then add in that part and keep going back and forth until we've got the button set up and working. And then also, then next up we'll do an LED. So the first thing, if we remember the symbols that I covered in the lecture, the switch, at least the momentary one, looked like this. You're literally taking this and let's see if I can get on to pushing it down. So we've got that momentary switch in there now. And so we can take that and then we can say, well, we need some way to measure what the switch is doing. And so we're gonna take that switch. I'm just gonna place it right as far up as it'll go, bridging across from one side to the other. And then I want to add in the ability to read a value from there. And I'm going to read on pins 2 and 3. So right down here, 2 and 3. I'm going to read the values from the 2 switches that we're going to add. And to do that, I need to connect a wire, which these are the jumper wires that come with your kits. If ever, don't be super surprised if one ever stops working. If you ever run too much current through them, or if you're not kind to them, they do break. But what we can do is take one of these wires, and what we're going to do is draw up from there and over and say, from here, I'm going to hook it up to a pin, and I'm actually going to say that that is pin D2. I'm going to do exactly that. In the third row down, I'm going to take that wire and put it in there. I'm going to switch over to the other view real quick. So third row down, and then go over to pin 2 and plug it in there. And that is, pin 2 is actually the third one up. It's a zero-based system, unlike MATLAB, which starts with 1. So third pin down from the top on the breadboard, because the switch is all the way to the top, and then third pin up from the bottom, because that is actually pin D2, or the digital pin 2. So now we've got at least some connection to the switch, but right now there's no electricity going to that, right? And we need to know, is it a high value, 5 volts, or low value, 0 volts? And so we need to supply those. And we can do that by saying, well, what do we want it to be when it's just not pressed at all? And so there's 2 ways to think about it. You can make a switch that is gives you the logic of 0, it's off, and 1, it's pressed, it's on. Alternatively, if you switch the wires around, you can say it's on, or it's not pressed, but the signal is high, and so you get a 1, and if it's not pressed, you get a signal of 0. So what we're going to do, I'm going to do a pull down resistor. And so what we can do is say, if we're going to pull down, that means we can take this and draw a resistor in here and then go to ground. And so this is ground. And this is our resistor, which I'll use a 2.2 kilo ohm resistor. And these are the red, gold resistors. And I'll show you a calculator in a minute. So the red's easy to remember. But what we can do is then connect that to the blue line over here, one end into the blue line, because that's where we're going to hook up ground, and then the other one going right into the same row. Let me do that again. The same row as that pin that we're measuring, or we're trying to get a signal from. And so ground through the resistor to the pin. And then, so now we've got, in theory, a connection to ground, but we haven't actually hooked up ground yet. So what we can do is grab another wire. I'm going to use this blue wire and say from that blue line, I'm going to wire over and plug into, there's a ground right here, which is the fourth one down. 1, 2, 3, 4. And so now we've got a button that is plugged into ground. And we still, at least whether we press the pin or not, we're going to see a value of 0 because it's pulled to ground. We won't have a floating pin, it's called, which if you don't have it connected to anything, and if you don't specify a pull down, I believe the Arduino will just have the pin floating, and you may or may not get noise in there depending on what you're doing on the board. We have it pulled down, so we won't see that anymore with a fairly large resistor, but not as large as some of the built-in ones. So what we can do then is say, well, that's good, but across from one side to the other, from the bottom to the top of the switch, oh, wrong one. From the bottom to the top of the switch is where we're making the connection with this particular button. And actually, if I connected the wire over here for this type of switch, I'm still connected all the way across there. I'm not going to do that. I'm going to keep it on the same side and keep this hopefully a little easier to understand. But we've now got the switch pulled down to ground. We've got ground plugged in. We need some other signal coming in through the switch to say, this is what it's going to be. And so what we can do is then say, well, we want a supply of voltage. And so on the other side of this, we can say this goes to 5 volts. And so when we pull this, or when we put the other side up to 5 volts, then we'll be able to use the logic to actually read a signal if the button is pressed, or 0 if it's not pressed. 1 second, I think I'm about to sneeze. I'm back. So what we're going to do is grab another wire, just like I said. I'm going to grab a red wire and go from this bottom spot down here over to 5 volts, which is, again, the fourth one up from this break. 2, 3, 4. Fifth one down from the top on the left-hand side. And so now we've got 5 volts on this side. We could even connect the two sides together if we wanted to, and have now both of those to 5 volts. And once we have that, now we can use any of the available spots on those vertical lines. We might as well tie ground on the other side as well. Let me move this one down 1. Tie ground on the 2 sides across the top. I'll just show you, it's just tied right across the top there. And now we need to hook a wire from 5 volts up to that switch. And we can do it on either side of the top of that switch. And so I'm going to grab a red wire in this case. As much as I can, they don't give you enough red, green, black wires. Tend to lean towards green and black for ground, and red for any 5 volts, and then all the signals you can use different colors for. So really it doesn't matter too much, it's just easier to keep track of. We can go from the 5 volts up here to that top row for the switch, and then we've got essentially that circuit that I'm showing you in this picture. Oh, not MATLAB. In OneNote, maybe. Oh, now OneNote's not cooperating. Fantastic. Give me a second while I fix this. Hey, it showed up again. Um, so now we've got this complete circuit here where we've got 5 volts going through to the switch, which if it's pressed, then we'll be able to measure that 5 volts on the pin because it is closer at that point to the 5 volts. There's much less resistance in this line going through the switch to the 5 volts as observed by that pin. If it's open, that means the switch is like an infinite resistance, right? Or close to, because it's effectively like the air gap in between those metal contacts. And so the closest voltage value that it can observe is ground. So it goes through the resistor, the 2.2K ohm, and then to ground, and it'll measure ground. So if I were to head over to MATLAB and let's see, let's comment. This is some of the code that I used in an earlier video. Let's just comment out the previous one and let's read LED state. We can read pin 2 in this case. So again, we're setting an initial variable, initializing it. We don't even need to do that because we're initializing it as soon as we get into the loop. We're setting that value equal to the value read back from the read digital method or function sitting on the Arduino class, which I even want to, I am sure between the last video and this one, I have lost the serial connection between my Arduino and the computer. So I'm going to say Arduino object is equal to Arduino and grab a new connection and then go through and run that program. So before I do that, one way I can make sure that I've cleared out any connections before that is do a clear all, and I can clear out everything from the command window using CLC. And then I can also, because I'm paranoid and I don't like this to happen, I'm going to use that INSTR reset. And what that does again is clears out all the serial port communications and essentially like resets the Arduino for you. And so it like almost 100% of the time guarantees that you will be able to reconnect to it with the next line, which is grabbing a new or setting up a new Arduino object or creating a new instance of the Arduino class, the object. In this case, I named it ARD object. And then going in and going through this loop 1,000 times, which I just realized is a substantial amount of time. We'll do 100. And reading the digital pin, and it'll print out because I don't have a semicolon at the end, and then it'll pause for 1/10 of a second and keep going through there. So let's pause even a little bit less time. 0.05 seconds. And then we can run this. So let's save. And what I'm going to do, I'm going to set up a new folder to work in. So I'm going to go, I have 1301 stuff from previous years. I'm going to, in my 1301 folder, I'm going to create a new folder and call it ME 1301 Spring 2021. Everyone thought we weren't going to make it, but here we are. And then I'm going to save this, if it'll let me. Interesting. I forgot where save as is. Found it. It's on the editor tab. So you can click the down arrow and do save as. And then you can pick the spot. If we go to the same folder. One second, I'm getting there. And we can save it. And now it shows up in that folder. And I can say, let's run this. So right now it's reading a bunch of zeros. When I press the button, I get 1 value, let go 0, press 1, let go 0. Much more responsive than what I saw in the last video. Excellent. So now we're able to read from that button. And so we could use it for something like we did with the button if we want with the LED. And so if we wanted to blink that LED again, I'm going to have to kill this code. And the most effective way that I have to do it, or what I do if I'm programming with MATLAB and the Arduino, click on the command window, Control C. If you try to hit the pause button and stop it that way, it takes you into like a debug mode. And there's a bunch of Java code that's running behind the scenes to try to work with the Arduino. And so it like pulls up these random files that are confusing to people that are relatively new to programming. So easier, friendlier way to do it, click on the command window, press Control C. So we killed that. And then if I were to run this again, now I should actually see that LED turn on or off each time. So let's run it again. And right now it's running, LED is off. When I press it, that red one turns on. So whenever I push the button, it's sending that information, the LED state, the variable that just got updated, sending that value as 0 or 1 to digital pin 13, and it's going from 0 volts to 5 volts to 0 volts back and forth. So now we've got our first switch, and what we can do is duplicate that. We need a second switch, but what I'm going to do, because it is duplicate, is I'm going to show you how to do an LED first, and then essentially from there, it's like you physically cutting and pasting the circuit for the rest of it. So let's now look at what we can do for adding an LED. If I can find my mouse. There we go. So we want to add an LED. And all we need to do is make sure that we're not going to put too much current, try to request or like allow too much current to go out of the Arduino pin, which some of the chips have like kind of built-in protection to stop you from doing that. Some of them don't. To be honest, I don't remember if this particular chip is or is not friendly to people making mistakes like that. We're not going to chance it. So what we can do is we want essentially the electricity go through a resistor, have the amount of current limited by that resistor, and then go through an LED and then go effectively funnel through to ground. And so we're going to do exactly that. We're going to say from 5 volts, we'll go through an LED. And this is where the little light will shine from the LED, the light emitting diode. Or I said resistor first, didn't I? Let's back up and do that then. We'll add a resistor first. And then we'll do the LED. And then we'll go over and you'll see different versions of ground. Normally it's 3 lines. I only drew 2 last time. It's, again, probably more of my drawing skills than anything. So that's going to ground as well. So we're going to see, again, the flow of electricity go through that resistor, limited by the resistor, go through the LED, essentially like allowing it to emit photons, or what we see as light, and then go through and go to ground. So we grab one of the LEDs. Now with LEDs, there's two sides to it, the anode and the cathode. And we want the longer lead, the anode, to go to 5 volts or to the higher voltage. And so we're effectively saying that the electricity can flow through in that direction. It will not work in the opposite direction. And so before you say, my LEDs are broken, you should possibly try to switch the direction of it. If you're not sure which one the longer lead is, there's also a flat side which goes to the cathode. And so it's probably impossible to show on this video. Yeah, I doubt it. But if you look really close and hold it up to the light with these red ones, you can see that there is a flat side. And so the flat side goes towards ground in this case. And we could even hook it up directly to ground. I'm going to start with row 10 and put the long side into row 10 and then the short side into ground. Just like that. And then what I will do is I'm going to pull up a So there's a bunch of resistor calculators that you can find online. I actually have one on my phone, which I've enjoyed over the years. I believe it is free. It's just called Resistor, and it's literally a resistor calculator. So you can get one for your phone, or there's a bunch of ones available online, which let me just pull this one up. And so what we're going to do is grab this green, blue, brown resistor. And now you can keep track, you can actually calculate what these are. I tend to just use the calculator just because I haven't taken the time to memorize everything. But these ones are just as I had hoped, the 560 ohm resistors. So you're limiting the amount of current going through there. If you wanted to calculate exactly how much is going through there, sometimes the LEDs have an internal resistance. Sometimes it's very, very minimal. But really, you're doing most of the limiting by these resistors. And so what we're going to request out of there is on the order of just under 10 milliamps, because its voltage is equal to current times resistance. And so if we take the 5 volts divided by 560 ohms, then we're going to see, just like I said, something just under 10 milliamps. And if you remember from the lecture, we can ask for up to 20 milliamps from the pins without running into any problems. So what I'm going to do is take that 560 ohm resistor, and just like I showed in the find a better way to quickly switch over to OneNote. I'm going to put this in right next to the LED. So going into row 10 and then jumping over to row 11, just going down one row. And then from row 11, I'm actually going to hook it up to the first pin that I'm going to use to control the state of the LED. And so I'm going to supply the signal from the pins, and it will be enough current and high enough voltage going through there to turn the LED on, or if I want it off, turn it off. And so I'm going to take one of the shorter jumper cables. Let's go with yellow. Again, color not important unless you're really into tracking what you're using them for. I'm going to put one end into that row 11 and then jump over, and I'm going to go with pin D4. So I'm going to use the first two again, 2 and 3 for the switches, and then I'm going to use 4, 5, 6, 7, 8, 9 for the LEDs in this circuit. And so now I've got the first LED hooked up, and I can go back over to MATLAB, and if I wanted to now, I could do this exact same piece of code that I have that I used to test to make sure the board worked initially. And I can say, instead of pin 13, which I know is an LED that works, I can say for pin 4, I want to turn on that LED or turn it off based on what I'm doing with the switch. So if we run this code now, so right now it's off, I press it and the LED turns on. I let go, it goes off. So it's just like the pin or the LED on pin 13, but now I have a new one hooked up to pin 4. So what I'm going to do now is I'm going to, if we go over to OneNote, I'm going to do this same thing. I set it up initially for D2. I'm also going to wire one up to D3. So the exact same circuit, I'm going to wire up to D3 instead. I'm still going to hook it up to 5 volts and ground with the 2.2K ohm resistor just like I did. But that pin right here is now going to be hooked up to D3. So now then we'd be able to have 2 switches. And why don't I do that and then come back and I can show you it working. See you in a minute. All right, so I added the extra switch in there again, going from 5 volts to the switch on the top row, which is this green wire I've got. And then on the bottom row, I've got a wire going to pin 3, a resistor going to ground, and then that's all I need for the switch. And so I have a pull down resistor to the pin and also to the switch. And then on the opposite side of the switch, I have it going to 5 volts. So what I can do is then head over to MATLAB. And I can say, well, what would be something more interesting for this? What if I said, I only want the LED to turn on when I have both switches pressed? So I can say, read the first LED state. We'll say LED state 1. We're not trying to get, people are probably like cringing at these names, but we're trying to keep it simple. So reading LED state 1 from pin 2, reading LED state 2 from pin 3. Well, that's kind of gross in itself. Oh well. And then what we can do in here is say, for the logic to send to the LED itself on pin 4, I'm going to multiply the 2 together. And so what that'll give me is that unless both of them are pressed, it will always multiply together to be a 0. And so if we say LED state 1 times LED state 2, and save that and click run. So what I can do is press 1, nothing happens. I press the other, nothing happens. But when I press both, then that LED turns on. So again, pressing 1, nothing, the other, nothing, and press both and it turns on. So now I've got 2 functioning switches and 1 functioning LED. What I'm going to do next then is, we go back over to OneNote, I'm going to add in LEDs. I started with pin 4. Now I'm going to add to D5, D6, D7, D8, and D9, the exact same thing. So a resistor from, you know what, I drew the wrong thing. I apologize, friends. We're not going from 5 volts. We're going from a pin. And so in this case, I started with D4. That's what we're replacing. So from the pin, we're seeing the electricity go through the resistor, through the LED, and to ground, and hopefully limiting the current draw that we have in the circuit with the resistor. So I'm going to add those in. Again, I'll pause the video now, but we started with pin 4. I'm just going to add in identical circuits and plug them into pins 5, 6, 7, 8, and 9. See you in a minute. All right, I'm back. I got my LEDs. A little hard to see here, but there are 6 LEDs hooked up now, so I have them wired up to pins 4, 5, 6, 7, 8, 9. What I'm going to do then is test it out and make sure they work. So we can comment out. Yeah, let's turn all of them on. So let's keep that logic in there. And if we really want to do it like the kind of like gross way, we can I tell everyone not to do this just for testing. So now we've got 6 lines that are writing that combination on or off to those 6 pins, which please don't cut and paste code like this unless you're just testing out the circuit. But what we can do is now run this, and if I've wired everything up correctly, then we should see all the LEDs turn on at the same time when I have only both buttons pressed. So let's run that. So nothing, oh, now it's running. Nothing when I press one, nothing when I press the other. And then all 6 turn on when I'm pressing both buttons. And when I let go, they all turn off. What we could do is if we wanted to get something a little more interesting out of here, we can comment out some of the code. Get rid of all these duplicate statements. And say target pin, what can we set it equal to? We could say, let's test something. 1 second. All right, so what I'm doing is most of my programming I do not do in MATLAB. And so what I'm doing is just testing how MATLAB adds different variable types together. So if I wanted to say d plus 9, it actually does return a string that is d9. And so what I can say is target pin is equal to d. And then what could we use? We could use 4 plus, what's the modulus? So modulus, it's essentially like divides a number by another one and gives you the remainder. So what we could say is we've got 6 pins. So what would be a good one? 4 plus modulus of I comma 6. Right? And so now as we go through here, we'd have the modulus of I. Let's say I is equal to 2. And then we could say modulus of I comma 6, and we get 2. But if we also said modulus, or better yet, I is equal to 8, and now did modulus I comma 6, we get 2 again. And just like any other number, you're dividing by that number, and then you get the whole number remainder from that division. And so we're going to go through here, and as I goes to 1,000, we're going to be left with that chunk, which we can add to 4. It's going to range from 0 to 5. And so we'll be addressing pins 4, 5, 6, 7, 8, 9 each time. And what could we do to make it act strangely? Well, let's just say let's start with an LED state out here equal to 0, and then we'll switch it each time. So the opposite of LED state 1. And we can get rid of LED state 2. So we're going to go through and turn them on, and then we'll see how it goes. This will look strange. It's only turning on 1. Interesting. I was hoping for something different. It is getting different target pins. Let's kill the code. 4, 5, 6, 7. It's going through each pin just like we wanted to. Oh, it's writing to D4 each time. I meant to swap out. We can also, instead of the specific, I was looking at the code, instead of the specific pin, we can specify some variable that we've constructed in another way, right? So target pin, I'm now going to have, just like target pin is outputting here, a different pin each time. So let's run this. I have a feeling because I have an even number, it's going to turn on initially and then just stay on or off for each one. If this logic is correct in my head. Yeah. So what could we do with LED state 1 to be more interesting than just turning 1 on or off? We could say what's another function we could use? We could say sine of I and then round it. That would give us very different values, right? So we could say sine of I plus 1, all of that divided by 2. We want it to be between 0 and 1. So now it's from 0 to 1, oscillating up and down. And then I could say round that value. And so it'll always be a 0 or a 1, and it'll depend on the I value. I'm hoping for something a little more complex than just 3 of them turning on. Slow movement. It's more interesting. Let's multiply it. Let's multiply I by 4 and see what happens. Speed it up a little bit. There we go. It's the kind of stuff you see from like 80s sci-fi movies. Sweet. All right, so that's the circuit build for this week. Next set of videos will be focusing on actually trying to tackle the programming challenges for the week. So try the lab before you watch the next set of videos for the week, because this is all you need to complete all the tasks. So again, you are trying to do these tasks to learn the material and also hopefully prep yourself for the quizzes that I will throw at you each week. That's all I've got. See you in the next video.